Hi, everyone. My name is Ellie Ventiger, and I am a meteorology student here at Texas Tech. So you'll see me on and off throughout the day. Hopefully this will be a fun time for you guys. We have lots of fun experiments and videos for you guys to see. So thank you for attending our 15th annual Severe Weather Day. Unfortunately, we couldn't be in person this year, but hopefully it's still fun for you guys and you learn some things. Our first activity is going to be a few videos from both our National Weather Service, so these are the people who make our forecasts, and our broadcast, so these are the people that help communicate these forecasts. So our first one is the National Weather Service.
Hi, I'm meteorologist William Iwasco here at the National Weather Service office in Lubbock, Texas. Did you know that there's someone in this office 24/7, 365, making sure that we keep an eye on what's happening weather-wise so that you guys can stay safe when you're at home? Now, in order to do this, we rely on a lot of technology, from satellites that are way up in space down to more local things that we ask people to put out in their yards to measure how much rain has fallen across the area. All of these tools help make sure that we know what's happening around this area. Now, you're going to learn a little bit about weather watches and warnings and how to stay safe during severe weather. But before we get to that, first we have to talk about what actually drives the weather, and that's water. So to learn more about the water cycle, here's meteorologist Jen Daniel.
Thanks, William. Did you know that our oceans cover about 70% of the Earth's surface and hold over 97% of the water on our planet? Water is very important to weather. For one thing, without it, we wouldn't have clouds. The sun helps to power the water cycle, which starts with water on the Earth's surface evaporating, meaning it goes from a liquid to a gas. As it rises in the air, it cools and condenses, going from a gas back to a liquid, and makes clouds. When the cloud can't hold any more water, we see precipitation, bringing all that water back to Earth to start the process over again. Now that we know how water makes clouds, let's talk more about how a cloud becomes a thunderstorm. Meteorologist Harrison Sienkiewicz, take it away.
Thanks, Jen. Thunderstorms actually start as just a few small clouds, which often grow into puffy clouds called a cumulus as the day goes on. You may see rain from these, but it is the huge cumulonimbus clouds that make all the noise. These clouds might look like cauliflower on the edges and have a long, flat top called the anvil. Sometimes they even have a dome seen above the anvil, and this is called the overshooting top. An overshooting top is a sign that the storm could be severe. In fact, here's William to tell you what kind of severe weather might come out of a cumulonimbus cloud.
Yes, a thunderstorm can produce a lot or no severe weather at all. Now, when severe weather does occur, these are some of the hazards that you need to be careful of. Lightning, which can be hotter than the surface of the sun, can cause injury if you're outdoors. Hail can range anywhere from the size of a pea up to a softball or even larger, which can do quite a bit of damage if you're outside. Winds that blow just in a straight line can knock down trees or cause damage to power lines and homes. Tornadoes, which spin across the land with winds of 65 miles per hour or greater, and can do major damage to structures along its path. And finally, flooding, which is caused by very heavy rain. Now that you know what these hazards to be on the lookout for, let's learn how to stay safe from them.
At the National Weather Service, we issue watches and warnings to tell you when severe weather might happen and when it's definitely happening. To tell the difference between a watch and a warning, you can think of it in terms of baking a cake. A watch is like when you have the ingredients ready. The ingredients are coming together to make severe weather. You should be preparing and reviewing your safety plan. A warning is like the finished cake. The ingredients have come together and severe weather is happening. You need to act now. Remember, most days in West Texas are pretty nice, but we do have those days when the weather will be severe, and we want you to be prepared. First, we have a saying about lightning. When thunder roars, go indoors. This means that no place outdoors is safe from lightning. You should go into a house, school, or other well-built building and wait 30 minutes until the last thunder is heard.
When hail and winds start whipping out of a storm, you should be indoors. Make sure you stay away from the windows in case they break.
Speaking of being indoors and away from windows, that's where you'll want to be if a tornado is coming. In fact, you should find the lowest spot to the ground as possible and in the most interior room of your house.
If you're at school, you probably did a practice tornado drill. Always listen to your teachers during these so you know what to do at school during a tornado. Oh, and we haven't talked about flooding yet. Kids, it's never safe to play in floodwaters. The water might be moving fast and there could be things under the water that could hurt you. Also, tell your parents to turn around, don't drown. You never know how deep the water is, and it only takes a foot of flowing water to wash away your car. Speaking of parents, when you get home tonight, why don't you spend a few minutes talking as a family to make a severe weather plan? Know where your safe shelter will be and where to meet if you get separated.
Well, that wraps things up from here. Hopefully you've learned how to recognize and be safe from severe weather. Now, don't worry if you've forgotten something already. We are including a link to more information that'll help remind you about what you learned and also to explore some different topics that we didn't have time to explore. Also, there's a severe weather safety plan that you can sit down with your family and fill out, and then put it on your refrigerator so that you'll always know where your safe place is located. From all of us here at the National Weather Service office, we thank you for joining us.
Is going to be from KCBD, which is one of our local news stations here in the Lubbock area. And they're going to tell you what a broadcast meteorologist will do.
Welcome to the KCBD studio. I'm Steve Devine. I'm one of the forecasters here at News Channel 11. So when we're talking about severe weather, what really are we talking about? Well, the classic definition, that is the definition that's used most often, is whenever we have a thunderstorm that might produce wind gusts of at least 58 miles per hour or stronger, a thunderstorm that's producing hail of at least 1 inch in diameter, or a thunderstorm that produces a funnel cloud or a tornado. By the way, the difference between a funnel cloud and a tornado is a funnel cloud that has contact with the ground. That's the difference between the two of those. Of course, the strength of a tornado can vary dramatically from weak ones to very strong ones, which can do catastrophic damage. We have a lot of snow in our forecast, blizzard conditions. We would consider that to be a type of severe weather, and really heavy rain that might result in some flooding in the area too. Now, there are times of year where we expect to see more severe weather than at other times. Now, I want to point out that severe thunderstorms, severe weather can and has happened in every single month of the year. So it can happen anytime. It's least likely in the colder months. It's most likely, though, towards late spring. Right here in the Lubbock area in particular, peak would be towards the end of April, early May. But it ramps up towards that. Sometimes we get severe weather as early as February and it continues to build up. And then after that mid-May period, it starts to drop off, but it doesn't just cut off real quick. It's just a process, gradually builds towards the peak, and then we see it ease a little bit. And then especially towards late June into early August, it's usually pretty quiet. We get some thunderstorms, but we don't see that many of them that become severe. Some of them produce some very heavy rainfall, however. Then towards late August through much of September, we're looking at what we sometimes call our second severe weather season, where we have the potential, again, we see this little uptick generally in the stronger storms. Some of them become severe. Now, the storms typically earlier in the year have a higher potential of producing tornadoes. The storms that come during that second peak that I mentioned, that late August into September period, they tend to produce a lot of the strong winds and the really heavy rain that we sometimes see with the stronger storms here across the South Plains area. So during severe weather, we'll be talking about watches and warnings. And the difference between them is usually a watch means that heads up. This weather is likely going to happen, perhaps in the next hour, perhaps in the next 6 hours, depending on what type of weather we are talking about. And that warning means that this weather is imminent. That is, it is about to occur or it is already occurring in the area. So there are different actions that you take. When there's a watch, you should have a plan. What will I do if this weather actually occurs? For instance, a tornado watch. What would I do if there's actually a tornado that's moving toward my area? Now, in a warning, there's a tornado in your area, so that's when you should be taking cover. Now for a watch, it's going to be issued generally for a very large area, perhaps all of the KCBD viewing area, a large part of West Texas, eastern New Mexico. A warning is typically going to be issued for parts of a county or perhaps several counties, depending on where that exact storm is. Another difference, a watch, again, which is issued in advance of this type of weather, is usually going to be in effect for an hour to several hours before that weather is anticipated. A warning, it could be 20 to 60 minutes, but sometimes the warning in case of a tornado, for instance, a severe thunderstorm, might even be less than that 20-minute mark. Now this is for the severe weather typically associated with thunderstorms. If we're talking about winter weather, we have similar terms. Watch is for a winter storm that's expected, but that might be issued 24 to even 48 hours before the weather actually moves into the area. And then if we have a winter storm warning, that might be issued about 12 hours, maybe 24 hours before that storm actually moves into the area. Part of our forecast center, where we put together our forecast, includes what we call the green wall. This behind me is actually a green wall, just painted green. And the reason that it is there is because it allows us, through computers, to actually show you many different images rather than this green wall. What happens is the camera that you're looking at right now is showing me in front of the green wall. We then use equipment which kind of like takes scissors and cuts out all the green and gets rid of it. And then we can take any other image, a video, a picture, a graphic, a forecast, radar, and make it look like it's right there behind me. And that way I can tell you the story of what's going on, and we can move seamlessly from one image to the other. Thank you for spending some time with us today. When severe weather does strike, just a reminder, weather radio is a great resource to get watches and warnings. Our free KCBD weather app on your phone or your other mobile device. Tune into your favorite weather coverage station, such as KCBD NewsChannel 11. And remember, when thunder roars, go indoors.
Okay, great. So that's a little bit of what a broadcast meteorologist will do. And our third and final video for you today before we get into our experiments is a little bit about what research meteorologists and students do here at Texas Tech. And
what do you think of when you hear the word meteorologist? Do you think meteor? Close. Meteor actually means things that are high in the air. So, a meteorologist is someone who studies things that are or have been suspended in the air.
Hi, my name is Jillian. I'm a meteorologist and a graduate student at Texas Tech University. As graduate students, it's our job to study and understand how the weather works, especially severe weather. There's still a lot we don't know about severe weather in the meteorology community, so that's where we come in. We are learning more and more about weather each and every day. We do research in order to better understand how things like thunderstorms and tornadoes form. We use different tools to measure different factors or recreate what's happening in our atmosphere.
While it's dangerous to get close to a real tornado, in a lab, we can use large fans to create our own small-scale version. Even though this is only a model and not an exact replica of what happens in nature, it's still able to give us valuable information. Speaking of tornadoes, have you ever heard someone refer to a tornado as an EF4 or an EF5? Have you ever wondered what those numbers meant? The EF stands for the Enhanced Fujita Scale, and the number relates to the amount of damage that has been done by the tornado. It's a scale that ranges from 0 to 5, with an EF0 being the weakest tornadoes and an EF5 being the strongest, most damaging tornadoes. But how do we know that a certain damage pattern corresponds to a given wind speed? To answer this question, researchers needed to conduct experiments. This was done at the National Wind Institute located right here in Lubbock. Researchers used both a wind tunnel and a debris cannon to see what happens at given wind speeds. For example, scientists can load a piece of wood, commonly referred to as a 2x4, into this cannon and launch it into a variety of objects to study the results. While lab experiments are important, Meteorologists also need to understand and measure what is happening in the real world. You might have heard of meteorologists in the past use the word radar when discussing a forecast. We use these in order to measure and look at precipitation. Inside a radar's dome, which is an outer shell that protects the sensitive instruments inside, a dish spins around and an antenna sends out radio waves. These waves bounce off a storm and return to the radar. By measuring how long this takes, we know where a given storm is located. We also have the ability to put these radars on trucks. This helps us get closer to the storm so we can gather more information. We call these mobile radars. Radars can give us a lot of information, including where and how much it's raining, whether a storm is producing hail or snow, along with other weather phenomena. However, radar is not the only tool that we use. For example, one of the instruments we use is called a sticknet. Sticknets collect valuable information such as wind speed, wind direction, temperature, etc. The benefit of these particular instruments are the fact that they are light and mobile. Given that we have 4 trucks and each truck contains 12 sticknets, that means we can get a lot of data points in areas we are interested in. Sometimes these are used for hurricanes, and other times they are used near supercells that can produce tornadoes. While this is helpful, these are not available all the time. Therefore, we need permanent weather stations. These stations are located throughout the U.S. in all 50 states and can appear differently depending on their purpose. Some of these towers are really tall. These help us get measurements off the ground where it's hard to reach. Here in West Texas, we are very fortunate because we have our own local weather station network called the West Texas Mesonet. There are over 115 of these stations located throughout West Texas. They report information such as temperature, wind speed, rainfall, and relative humidity. While this real-time information is incredibly valuable to us as scientists, it's also available to the public for free. All you need to do is download the West Texas Mesonet app. Once you do that, you can see a lot of information. These are just a few of the tools that we use to gather information about our atmosphere. Whether it's a tornado simulator, sticknet probes, Mesonet stations, or radar, these tools give us, as research meteorologists, the information we need to make better forecasts in order to keep people safe during severe weather.
Research meteorologists like me help provide better information about how storms form to the forecasters at the National Weather Service and broadcast meteorologists at TV stations. Our goal is to all work together as a team in order to send out the best forecasts for you and to keep people safe. Make sure you're talking to your parents about your safety plans if there's ever severe weather in the area. Thanks for tuning in. Have a great day.
Awesome. Well, so those are basically 3 of the main branches of meteorology. If you have any questions, again, please put them in the chat. After I speak about safety a little bit, we'll have chances to answer that. So in the videos, we mentioned several times having a safety plan. So what does that mean? Well, first you need to be able to get your warnings. So that can come through outdoor sirens. Maybe you get a notification on your phone, or that we have something called a weather radio. You should ask your parents if you have one of these, and if not, you should look into getting one because they're really useful. They can wake you up at any time of night if you really need to get an alert, a weather alert. They also will still work even if your internet goes down or your electricity goes down, which can be really useful because if you have severe weather, that might happen. The other thing is, once you have the warning, what should you do? Well, we always tell you if you hear a tornado warning, go to a sturdy shelter, so a house, a building, something like that. And then once you're in that building, go to the most secure location. That means the lowest level, so if you have a basement, that's great, or the first floor, and then an interior place. So that means somewhere away from walls that border the outside or windows. Often a bathroom is a great place, maybe even getting in your tub. And the other thing you can do is if you hear a tornado warning, you can grab your closed-toed shoes, like tennis shoes. That way, if you need to, get out and move around afterwards, you are ready. And most importantly, grab something to cover your head with. If you have a helmet accessible, that's perfect, that's ideal. But even if you don't have time to grab a helmet, You can grab like a blanket or a book, just something to cover your head with. Also, don't stand outside trying to look for it. We'll send you pictures after the fact, but you just need to get in your safe place. So with that, any questions?
I don't see any questions in the chat, so we'll talk about, oh, never mind, one just popped up. Have we ever had an EF5 tornado in Lubbock?
Actually, we have. We had a really historic tornado that went through in the 70s. We just celebrated the 50th anniversary last year, and we talked about it a little bit in that video. But the EF scale, that scale that we use to rank damages on, a lot of study went into the tornado that went through Lubbock, and that's how that scale was developed. Any other questions?
Yep, our next one is, how deep do the floodwaters get?
Oh, they can get really deep. It really just depends on what's causing the flooding. If you have a hurricane, for example, you can have flooding of 20 feet, very deep floodwaters near the coast. If you have just rain that's causing the flooding, a couple feet, a couple inches, but it really doesn't take a lot to be really serious, because only a foot of water can move a car. So that's why we tell you, turn around, don't drown. If you don't know how deep that water is, stay out of the water. Any others?
Sure, the next one is, what materials is a safe room storm shelter made out of?
Typically, they're made out of some sort of concrete that's been reinforced by steel. That's, I think, the main building material that I know of. Awesome. So now we have some experiments for you. Our first one is going to be about why and how clouds form. And again, keep putting those questions in the chat. We'll either answer you in text form or we'll answer them live.
All right, good morning, everybody. My name is David P. Queen. I'm a second-year master's student at Texas Tech, and I'm studying lightning and hurricanes. So lots of cool possibilities for you all in meteorology. Now, today we're going to try to build a cloud inside of a jar. So I'm going to start with 2 empty glass jars for the moment, and I'm going to pour some very hot water into each of them. Nearly boiling water. You can see the steam coming off of this as I pour it. So if you do this in real time or afterwards with your own materials, you want to fill it so the water is just a little less than half the jar. And then I'm going to throw in some food coloring so it's easy to see the water as we develop our cloud. Now, of course, in the real atmosphere, we know that water is always evaporating from the oceans, rivers, and other water bodies in the real world, right? But for our experiment, what I'm going to do is I'm going to seal both of these jars. The first one here, I'm going to seal and place some ice cubes on it without introducing any other particles into our system. So in this case, we have the warm water heating the air particles above it. That warm air is rising and they're coming in contact with this sealed container. The ice on top of the container is creating a cool surface here, so those particles are then cooling down. But now in the second container, what I'm going to do is repeat that same process, but I'm going to introduce something new. So this is a can of hairspray. So we're going to provide some new particles into our air above the water. I'm going to repeat the same thing. I'm going to seal this jar and add some ice on top. And hopefully what we'll see is a cloud developing in the second jar, but not in the first jar. Can you see that? Yeah, here it comes. So what's happening here? Why is this happening? Well, in the real atmosphere, we know that clouds need some sort of particulate, some sort of dust, dirt, ash, pollen, something for the water to condense onto. So in our second jar here, we've given those particles. We've given the hairspray particles where the warm water again is rising up to the cooler surface at the top. It's condensing because it has something to condense onto. And with that, I think I'll open it up for questions.
Okay, so we have a couple of questions about how do you tell the difference between a normal cloud and one that's a tornado?
Very good question. So we know there's lots of different types of clouds in the atmosphere, right? You've probably seen the like high cirrus clouds that are, or stratus clouds that are very high in the atmosphere, those thin wispy clouds, right? And then tornadoes are commonly associated with supercell thunderstorms. So those are more from your like cumulonimbus type clouds. They start out as the big white puffy clouds, but then they go darker and darker as more condensation occurs, more water, more energy builds up, and tornadoes are one way for that energy to be released back to balance out the atmosphere.
Okay. Another tornado question. How does the size of does the size of a tornado depend on how much debris it's picked up?
No, so the tornado itself is formed based on conditions in the atmosphere. But of course, the strength, intensity, and size of a tornado does then influence how much debris it picks up. The larger the tornado, the stronger its intensity, the greater the amount of debris or destruction it will cause. So it's more like the strength of the tornado influences how much debris is seen.
Okay. And then how many tornadoes have been, what's the most number of tornadoes that have occurred within one day?
So in a single day, the record for number of tornadoes that have occurred is 359 on a single day. That occurred on April 27th. Pretty incredible number.
That was in 2011.
In 2011, a famous year among meteorologists. Lots of storm activity that year.
Yes. And last one, what is an Amble cloud and what causes a tornado to go so fast?
So a tornado, an Amble cloud is something that tornadoes form from. Now, a tornado spins very fast because, again, it's trying to release all this energy buildup. And a great analogy for this is if you think about in the Olympic sport, what is it called? The figure skater, yes. So a figure skater, like picture a figure skater with their arms stretched out like this. They spin relatively slowly at that rate, but as they draw their arms in, they spin faster and faster. And that's a similar idea with a tornado. Because it is such a thin column of rotating energy and mass, as it gets pulled in tighter and tighter, it spins faster and faster. And that's how a tornado reaches such incredibly fast speeds.
Awesome. Well, our next experiment is going to be about rain.
Hey everyone, my name is Yannick. I'm from Germany and I came all the way here to study tornadoes. So if you have any questions about the weather in Germany or tornadoes, feel free to put them in the chat. So in the last experiment, we saw how clouds are forming. But not every cloud is producing rain, as all of you know. So especially if we have these really thin clouds, they never produce rain, right? These cirrus clouds that are really high. So in this experiment, we're going to show you when exactly rain is forming. What are the conditions for that? So what we need is a glass jar as before, then a plastic cup which has some holes in the bottom, some cotton balls which are going to represent our clouds, and water. So we're going to put some of the cotton balls into the plastic cup, which is going to be our artificial cloud. Stick them in there, and then put this on top of the glass jar. So right now the cloud is still really thin. There's not a lot of water in there, and of course there's no rain falling out of it. So what we want to find out is to see when exactly the rain is going to form. And for that, we're going to put more water into our cloud by putting water on top of our cotton balls here. In the beginning, we see nothing because there's not a lot of water in the cloud still, and that means that it's not saturated. But as we get more and more water into the cloud, we start to see that rain is forming. And that is because the cloud is getting saturated. So there's a lot of water in the cloud, the drops are getting bigger and bigger, and then they start to falling down because they're so heavy. At some point, the rain is going to stop again. We're going to have to wait a little bit. It's going to slow down to rain because there's less water in these cotton balls because all fell down to the bottom. And one more thing I want to show you is that I'm going to fill this up a bit more again. If I put my hand on top of here, it's immediately going to stop raining. And this is because my hand on top builds up low pressure in this plastic cup, And this low pressure fights against the gravity that pulls the water down. So it prevents the rain from falling in this case. All right, and with that, I'm taking any questions from you.
Okay, so we have a few more tornado questions. One question we have is, if you have a tornado that's picking up debris, where does it go?
Well, the tornado can pick up debris if it's really strong, especially, and if it goes over areas that provide the debris, so for example, houses. And this debris is going to travel with the tornado because it's just going to move around in a circle around the tornado. If it's really heavy, it's only staying aloft for a couple of minutes, and then it's going to drop down again, which is one reason why it's so dangerous to be near a tornado, because this debris can come down anytime and hit anyone. So you really want to stay out of the area of the tornado, even if you don't want to get too close to it, even if you're not in the tornado itself.
If a tornado is skinny, does that mean it's more powerful?
That's a good question. I know that doesn't mean it's more powerful. I would say overall, bigger tornadoes are more powerful, but it's not always the case. So small tornadoes can be really powerful and dangerous as well, especially because the tornadoes are strongest near to the ground. That's where they have the strongest wind speeds.
So what if you were in a car when there's a tornado coming, and if you have a standing shelter like a building, why is that better than going into a ditch? That's a really good question. So the winds from a tornado are actually strong enough to lift the car a little bit and to turn it around. And if you're in the car, you're gonna get hurt from that, because the car might get lifted a couple 100 meters, it rolls over the ground, and then you might get hurt. But if you're in a really solid building, then you're pretty safe, because the solid material, if it's, for example, stone, the tornado can't really penetrate that. And
hi everyone, how are you doing? My name is Sianja, and I'm also a master's student at Tech studying dust storms. So if you have any questions about dust storms or about hurricanes, I'm here to answer them. So just put it in the chat. Okay, so we know how clouds form, and also we know why they rain. They need to be saturated. So now today we're going to talk about hurricanes. Hurricanes are systems with lots of clouds that are rotating in the ocean, and they may come to the coast. So I'm sure you have seen a picture of a hurricane, okay? So today we're going to talk about how hurricanes start in the ocean. So we're going to see how it forms the eye of the hurricane. So hurricanes are formed in the middle of the ocean, but not in any place. They have to be in a place that is warm. Okay, so to simulate warm temperatures, we're going to use some candles here. So I'm going to put some candles in this ocean, and I'm going to turn them on. So let's do that. Okay, so we have water and we have heat. Now, what we need is to close a little bit this system to see the experiment. So something very important, and I'm sure you know because you have been in the science spectrum before, is that fire needs oxygen from the air to be on. Okay, so what is going to happen here when I close the system is that the fire is going to consume all the oxygen inside, and we're going to see something called difference in pressure. And for that we need to understand what is pressure. So pressure is the movement of molecules. So if I have lots of molecules in this side and just a few molecules here, and I remove the wall that is dividing the two masses of air, the part that has a lot of particles wants to fill the space in the place where there are just a few. So both of them have the same amount of particles. So that's going to happen in this experiment. So as the fire consumes all the oxygen inside, we're going to have less particles here. And as we have less particles, we create a low pressure inside of the jar. So once we have a low pressure, the higher pressures outside are going to try to fill that empty space. And that's what we're looking here. Can you see that the water is increasing in volume because the low pressure is trying to pull the water inside and fill the empty space. And this is how the eye cloud of a hurricane forms, and this is how they start. Do you have any questions about this?
Awesome. Which one is stronger, a hurricane or a tornado?
Well, that depends on the scale. Both of them can have really strong wind speed. However, tornadoes are usually smaller. Hurricanes can have the size of a whole state or even larger. So even if both of them have very strong wind speed and equivalent wind speed, tornadoes can affect only, for example, one county, but hurricanes can affect 3 or 4 states. So both of them have the same strength, but they affect different places, regions.
Okay, how far inland can a hurricane travel?
Inland, well, not very far. They can go maybe hundreds of miles inland, but the reason why they don't go all the way to, for example, the Midwest in the United States, it's because hurricanes are driven by wind. If the wind is strong, then they can travel a lot. However, in the ocean, since it's very plain and we don't have any object that can stop the hurricane, it keeps going. However, when it approaches to the land, we have objects. We have trees, buildings, people, and even the ground itself that tries all the time to stop the wind. And that is the reason why when a hurricane approaches to the land, they slow down and eventually disappear.
Okay, last question. How long does a hurricane last and how big can it get?
Okay, hurricanes need around a week to form and to be like really strong, and then they can travel and last for 1 week more around. And what's the rest of the question?
How big do they get?
Okay, how big do they get? They can be up to 50 miles in diameter, so 50 miles.
Hi, everybody. I'm Russell. I'm a PhD student at Texas Tech University, and I study the computer models that we use to forecast the weather. So what we're going to look at here is, this is a Van de Graaff machine, and this is a demonstration of how lightning works. So the Van de Graaff machine, this big globe has a positive charge, and the smaller globe on the end of the stick has a negative charge. And so you can think of this as the thunderstorm and the globe as Earth. And so what's going to happen is that electricity is going to jump between these two to balance the difference in charges. And we'll also see when we turn on the machine here that these streamers are going to float up. And that's because there's a lot of positive charge around this, and those positive charges are bumping into each other and moving away from each other.
We are going to turn the microphone off for just a couple moments because this machine does occasionally mess with our technology. So we'll resume the sound here in just a minute.
So when you hear thunder and see lightning, you're going to see the lightning first, and then you'll hear the thunder afterwards. And you can think of this like a firework. So when you're watching fireworks, you see the big bright flash first, and then you hear the explosion afterwards. And this is because light travels faster than sound. So you're always going to see lightning first, and then you'll hear the thunder.
Awesome. So we have some questions for you. How is lightning created, and what happens if you get struck by it?
Okay, so the first one, how is lightning created? In thunderstorms, there's a lot of turbulence going on. So the
water that turns into ice crystals in the storm bump into each other, and they knock charges all over the place. And so when these charges build up enough and they need to discharge, then lightning forms from the cloud to the ground or cloud to other clouds, and yeah, it needs to discharge that energy.
Okay, why is lightning, oh, sorry, I didn't, what happens if you get struck?
Yes, so if you get struck by lightning, it's going to be pretty painful. So you can get burned by lightning actually, because lightning is very hot, up to 50,000 degrees Fahrenheit. So if you know that a thunderstorm is coming, don't go outside to try to get a good look at it. Stay indoors and stay safe so you don't get struck.
Okay, why is metal or lightning attracted to metal?
That's a good question. I don't know the specifics of it, but mostly it's because of positive charges that metal has that the negative charge of lightning is attracted to. Does somebody else know more specifics about that one? No? Okay.
Wind plays an important role in weather, but where does it come from and how is it formed?
Okay, so wind forms because our Earth is rotating, and through this rotation, it's the gases in our atmosphere start to kind of curve a bit, and then all the air comes together in one location, and either it goes up or it goes down. So we have low pressure centers where wind comes together, and high pressure centers where wind will spread apart.
I like to think of it, if you had a bathtub and only half of the bathtub was filled with water because you had like a piece of wood in the middle or something, and all of a sudden you remove that piece of wood, well, that water is going to even out, right? So the water in our atmosphere is like wind.
That's a great explanation, yeah.
Okay, so we have a few more minutes so we can keep answering some other questions too about temperatures. Does a temperature affect a tornado?
It can, yes. So for a tornado to form, and more generally for thunderstorms to form, the surface of the Earth is going to be fairly warm. And so the sun heats the surface of the Earth, and then that causes warm air to rise, and we get thunderstorms to form sometimes. And then if these thunderstorms are very strong and they are spinning, then we will get a tornado.
Okay. How many times can lightning strike in one spot?
Lightning in one spot, is it 20 million times? No, oh, one spot, excuse me. I was thinking of the number of times it happens in a year. So lightning can strike in the same spot more than once, but it frequently doesn't.
Okay. So what is the most rainfall that Lubbock has ever received?
Lubbock has received 7.8 inches of rainfall in 24 hours.
And that happened September 11th to 12th in 2008. Okay. What about dust storms? That's pretty common in Lubbock. What is the most intense dust storm?
Well, we have two different types of dust storms. One is when the air only increases the amount of particles in the air, but we have other types of dust storms where thunderstorms are able to push the dust and we see walls or haboobs. So I don't know if you know, but during the 1930s, we have something called Dust Bowl, when we had dozens of dust storms, huge dust storms during the whole year. So there was one that was called Black Sunday, where we had a dust storm that was so huge that was able to travel from here all the way to Washington. And that happened on April 14 in 1935.
Okay. Why do you see lightning before you hear thunder?
That's a good question. So we see lightning before we hear thunder because light travels faster than sound. So you can think of it like fireworks. When you're watching fireworks, you will see the fireworks explode first, and then you will hear the bang afterwards. So that's very much how lightning and thunder work. You will see the lightning, and then very briefly after, you will hear the thunder.
Okay. how strong is lightning and does it often hit a person? And if it hits things, how much damage does it do? Like, can it start houses on fire or?
So lightning is very strong. As we mentioned earlier, the temperature of lightning can be up to 50,000 degrees Fahrenheit. And so if they were asking if it can strike someone, yes, lightning can strike someone. If your hair starts to stand up on end when there is a thunderstorm outside, or you feel the hair on the back of your neck rising, you will want to get down to the ground because lightning is looking for a path to connect to. And if you are one of the tallest objects around, it will connect to you.
So Xenia, I know you work on dust storm research. First, how far and fast can they travel, and can they harm people?
Okay, that's a very good question. So dust storms, the ones that are walls that are moving, also called haboobs, can move several miles per hour, and they definitely can hurt people. If you are walking on shorts during a dust storm, you can feel how the small particles cut your skin. So it's very important for you to stay indoors during a dust storm. However, there's something even more important, and is that the small particles suspended in the air are small enough to penetrate deep into our lungs and then lead to severe consequences. So especially if you have asthma, you should stay indoors during a dust storm.
Okay. So how far can a lightning strike travel? And is lightning only attracted to metal?
So lightning strikes, they can travel varying lengths, but usually they're pretty close to a thunderstorm. It's not necessarily directly below the thunderstorm. The lightning can take a path that's curved away from it and then hit the ground. And lightning isn't necessarily only attracted to metal. There needs to be the positive charge on something that can connect with the negative charge associated with the thunderstorm.
Okay. Can a dust devil be built up into a tornado?
I don't think so, no. So a dust devil actually occurs because there is warm air at the surface. And so this warm air starts to rise. And if it gets a little spin to it, then it'll form a dust devil. And that is not associated with a thunderstorm, but tornadoes are associated with thunderstorms.
Okay. What causes thunder?
So thunder is the result of lightning striking. And so since lightning is so hot, when a lightning bolt strikes, the air will expand very fast. And so what happens is when that air expands, the sound waves, it moves the air and creates sound waves that travel very fast away from the lightning bolt.
Okay. How warm does water have to be to form a hurricane?
Well, it has to be around 27.5 degrees centigrade, which is around 80 degrees Fahrenheit.
Okay. Let's see. How do you measure rain?
We can measure rain a few different ways. One of the more common ways that you might be able to measure rain is with a plastic rain gauge. Sometimes you'll see these given out at places like Swad if we have them around, but it'll have like a ruler on it in plastic that will show you how deep the rainfall was. We also have more sophisticated instruments at some of our observation stations that will weigh the amount of rain and then dump that out when it gets to a certain level.
Okay, how many lightning strikes are there a year?
So this is the question I was trying to answer earlier. Each year there's up to 20 million lightning strikes.
Okay, can tornadoes get, and this is going to be probably our last question, can tornadoes get hot? And if so, does temperature really affect them?
Okay, I'll take it. So tornadoes, as I discussed earlier, are a result of warm air rising at the surface, which form thunderstorms. So tornadoes are associated with warm weather, but tornadoes themselves aren't necessarily hot.
Awesome. Any other questions?
Our next question is, how do you become a meteorologist?
Okay, so I mentioned that you'll need math and science as well. And then you just go to college for it. So there's colleges all throughout the country that have really good undergraduate programs. And then, yeah, you basically just choose it as your career and keep up with the math and science. Any other question? Why are there different sizes of hailstones?
This is because, hail forms when we have really cold air in those storms, and it's being taken up into clouds, and ice forms as it's being brought up to these different levels. And the reason there's different sizes is because sometimes the clouds aren't as strong, so they can't be brought up as many times. So it's essentially like if you had a piece of ice and you were wrapping more layers of ice on it, the more times it goes up and down in the cloud, the more layers it forms. And so those are bigger hailstones.
Okay, dangerous to get too close to a tornado. How do we study them then?
Yeah, so it's definitely very dangerous to get close to tornadoes. So most of the observations and the way that we study them is through things, it's a tool called Doppler Radar. And this is at a lot of weather stations. They'll send out pulses of energy that as it encounters things like rain or hail within the tornado or in the storm, it can be returned back to the station so we can look at it from a great distance so we can stay safe while still studying these different conditions.
Definitely. You guys should not be out there trying to get a picture or study that. Leave that to the professionals.
Unless you go to school
yes,
to get that job.
Yes. So a question we have is, what are clouds made of and how do they disappear?
So clouds are made up of water droplets depending on the height of the cloud. Some of them are mostly water droplets. They can also be frozen droplets, just depending on where they are in the height of the atmosphere. They can also be a mix. So generally, whenever clouds disappear, it's just because the water vapor is not condensed anymore and you just can't see the water vapor up in the atmosphere anymore.
Okay. So why do clouds float in the air?
Clouds float in the air just due to the upward motion that we have here on Earth. They just, the upward motion from, like I said, down here on Earth, it's just holding the clouds up. And then when they get too heavy, gravity overpowers that upward pressure. And that's when rain starts falling.
Awesome. Any other questions? Oh, how much do they weigh, clouds?
Oh, goodness. That's a very good question. I honestly don't even know that answer. I don't think I've ever known that.
I don't think anyone knows that.
I wouldn't even know how to weigh a cloud.
Probably more than you think, since it's made of water.
Yeah, it's awesome. A lot of water.
So that will be on lightning travel.
Lightning can travel for very, very far distances. So in the tops of clouds, they can travel for like up to 100 miles. Near the surface, they can strike as far away as, I think it's 30 miles away from a thunderstorm. So even if a thunderstorm isn't directly overhead, but you can still hear thunder or see lightning, you should still go inside because lightning can still come out the side of the thunderstorm and strike things on the ground.
Okay, what makes thunder?
So thunder is caused by lightning. So what happens is lightning is a discharge of electricity. And inside that channel of electricity, it's incredibly hot. It is 5 times hotter than the surface of the sun. So that causes that air to rapidly heat up and it expands. And when it expands, it basically what causes is you get a wave of air and it hits other air that hits more air and it keeps going. And that makes a sound. And that's why you hear that rumbling sound as these waves are traveling through the atmosphere. So it's a lot like a firework. When you see a firework, you see the flash of light and then a couple seconds later, you hear the boom. It's the exact same process that's happening in lightning.
Awesome. So we're gonna move away from lightning for now. So both of you can answer these questions. How far can a hurricane move?
I can take that. A hurricane can travel hundreds of miles. So they often form off the coast, at least for hurricanes that affect the United States, they can form off the coast of Africa. And then they travel all the way across the equator and then they come up and hit the United States. So they can travel hundreds, thousands of miles.
Okay, what would you do if there is a hurricane and a tornado, and does that happen?
Yes, hurricanes and tornadoes often happen at the same time. Tornadoes are frequently inside of the storms of hurricanes. And so this is also a tough question, similar to when we have a tornado and a flood, because flooding often occurs with hurricanes. And so if both of these threats are present at the same time, you'd like to try to be indoors, but also at a higher level so that you're away from the flooding. So this is, like Isaac said earlier, this is something that's being researched currently. How do we effectively give warnings for those kinds of situations?
Okay, how do you know if there's going to be a hurricane, and how do we tell where it's going to go?
So hurricanes affect the coastal regions of lots of countries, but for the United States, it would be all along the coast, and it can also affect areas inwards, although that's usually more of a flooding risk than just the wind risk. So we model hurricanes. So we had a question earlier about computer models that help predict the weather. So what happens is we send out what's called hurricane hunters. So these are special airplanes, and they fly into the center of hurricanes, and they collect data all along the path through the storm, and we take that data, we put it into our computer models, and then we let the computer models use a bunch of math and predict where the storm is going to go. And over the last 30 years or so, these forecasts have become a lot more accurate. And so they make these forecasts, and then broadcast meteorologists will tell you when a hurricane is expected and where to evacuate to.
Okay, which one is stronger, a hurricane or a tornado?
So it depends. Tornadoes can be quite strong, but they're also very small in scale compared to hurricanes. And hurricanes are very large, but they can have very powerful winds over a very broad area. So they can both have high winds, hundreds, 100 to 200 knots. So they can both cause a lot of damage, but it really is a matter of scale. Tornadoes will be small scale damage, and hurricanes will be very wide areas of damage.
So what if you get hit from lightning? Can you survive?
Yes, so if you get struck by lightning, you can survive. However, because lightning is very hot, you can sometimes be left with burns. So even though it's survivable, it is definitely something that you don't want to experience. So you should definitely do everything you can to avoid being struck by lightning.
So what if you aren't in a house or a shelter when a tornado happens?
That's a good question. So you want to get to the safest nearby place. If there's any shelter nearby where that you can put something over your head or try to hold on to something, you want to get there. Yeah, there's
also, if you really can't find anywhere, you can go try to find a ditch, any low-lying area. You just really don't want to be in a car.
Yes, and if you can, again, in a low-lying area, and make sure to cover your head. So if you say like lay down on the ground, make sure to put your hands over your head if you can.
Also, don't go in an underpass. So that's a myth that goes around, that you want to go, when a road goes, it's a bridge that has a road on top of it. It's a myth that you want to go underneath there. You really don't, because that can actually make your wind stronger through there. So, what makes lightning so powerful?
Right. So lightning is so powerful because there is so much electrical charge traveling through the lightning channel. So inside thunderstorms, there's a lot of complicated processes that are happening where you are separating those positive and negative ions and those charges. And because thunderstorms are absolutely massive, you can build up incredibly large amounts of charge. So then when you get a discharge, when you get that attraction between the positive and negative ions, you just have a ton of energy traveling through there. And like I said, it's 5 times higher than the surface of the sun. So that's pretty intense. So it's just because of the scale of thunderstorms is why they're so powerful.
So this is an interesting one. We have scales to measure earthquakes, hurricanes, and tornadoes, but is there any scale to measure the strength of lightning strikes? And are certain lightning strikes stronger than others?
As far as I'm aware, there's no scale to measure the strength of lightning strikes. But I don't know, are there strikes that are stronger than others?
There are strikes that are stronger than others. So we have what's called a lightning mapping array. And we have that actually near the Lubbock area. And that can get a sense of how strong lightning is by detecting how electricity is changing outside of the thunderstorms. You can't measure lightning directly because lightning will destroy anything that it hits. But you can get a sense of potentially the magnitude of charge that you have in your lightning. And lightning, also you can have positive or negative strikes to the ground, and those can have differing magnitude. But any type of lightning is enough to hurt a human. So again, you can't just go outside and be like, oh, I hope I get a weak lightning strike, because that doesn't exist. So again, you want to go inside if there's lightning.
So what makes clouds white?
Light.
Yes. So the way that light hits a cloud and scatters from it is what makes it white. So clouds are very good at scattering light. And so instead of seeing a certain color, clouds will reflect all colors of light. And so we see white instead of other colors.
Okay. Why do we see lightning before we hear thunder?
So we see lightning before we hear thunder because light travels faster than sound. So again, like I said before, like the firework, you see the light of the firework before you hear the bang from the firework. It's the same with thunder and lightning. So you see the flash from lightning, and then the sound waves from the thunder will reach you later.
Okay. Can there be a tornado stronger than an EF5?
I would say technically it's possible, but the scale does not go past EF5, at least the modern scale doesn't. The original scale that was introduced by a researcher, Ted Fujita, right? Yeah. They go all the way up to F12, I think. But we haven't observed anything that we think is stronger than an EF5.
And part of the reason why that is that it is very difficult to determine wind speeds in a tornado. So the reason that how we give tornadoes scales is that we go out and we look at the damage that a tornado produces. And so if it's just a little bit of damage, we know, okay, this was a weaker tornado. If it's a lot of damage, we know it was a stronger tornado. An EF5 will cause complete and utter destruction. So you can't see any more damage beyond that to know, oh, the wind speeds were stronger. If we have a radar like you saw in the Texas Tech video we showed earlier, if you have a mobile radar near a tornado, you can get measurements of the wind speeds inside of a tornado, but that only happens if you happen to have a radar nearby. And we don't normally have that. So part of the reason why we only see EF5 is that an EF6 would look exactly the same in terms of damage.
Okay, thank you very much. So that's all we have for you today. If you have any more questions, feel free to let us know. Also, we gave your teachers packets with more information or experiments, so feel free to ask them questions if you have any further questions as well. And thank you very much for attending, and we hope we see you next year and hopefully in person.
My name is Jillian. I'm a meteorologist and a graduate student at Texas Tech University.
Hi, everyone. My name is Ellie Ventiger, and I am a meteorology student here at Texas Tech. So you'll see me on and off throughout the day.
All right. Hi, everybody. My name is Isaac. I'm a student at Texas Tech University studying atmospheric science.
All right. Hi, guys. My name is Cece, and I'm going to be showing you raining cotton balls today. So what?
All right. Hello, everyone. My name is Jessie, and I'm going to be using a bandograph.
All right, good morning, everybody. My name is David P. Queen. I'm a second-year master's student at Texas Tech, and I'm studying lightning and hurricanes. So lots of cool possibilities for you all in meteorology.
My name is Yannick. I'm from Germany, and I came all the way here to study tornadoes. So if you have any questions about the weather in Germany or tornadoes, feel free to put them in the chat.
Hi everyone, how are you doing? My name is Yanja and I'm also a master's student at Tech studying dust storms. So if you have any questions about dust storms or about hurricanes, I'm here to answer them.
Hello, I'm Lydia Bunting. I'm a graduate student in meteorology here, and my area of study is severe storms.
Hi everyone, my name's Matt Asel. I'm also a tech student here at Texas Tech, and I'm currently studying windstorm events. So,
hi everyone, my name is Michael, and I'm also a graduate student here at Texas Tech. And what I'm looking at is how cold fronts actually impact the lower part of the atmosphere here on Earth. And so what we're going to do today now.
Hi everybody, I'm Russell. I'm a PhD student at Texas Tech University, and I study the computer models that we use to forecast the weather.